Today we are going to be building an Amiga 2000 2 megabyte Agnus chip adapter, and we are going to be using this on our CDTV. So let's get to it. This is a design by LinuxJedi, which is based on an original design by Liv2, which is this board here. We've had this previously in the CDTV and we have not been able to get it to work. So because trying to debug on this is blooming awkward, we're going to transfer everything onto one of these boards, which is going to be a lot easier to debug because everything is spread apart. I mean, this one has got pins underneath and the chip on the top, and if you want to try and debug any of the signals, then it is a problem. Whereas this one has the chips separate, so we can easily prod them and so on. There's plenty of space in the CDTV, so that itself is not an issue. Also, we're going to be using turn pin sockets and not these chunky square things that are on this. I do apologise for the fact that I'm only using one camera. That is because my other camera has broken, and I'm trying to get it fixed, or at least fix it. I have an idea what the problem is. It's one of these little tiny flex cables, and I need to get hold of that from China. So it's going to be a while. Hopefully that will be done before the move. Otherwise, we're going to be on, well, I think we might well be on one camera for a while. Talking of the move, if you want to know about that and the reasons behind that, then the details are on my Patreon. That post is not behind paywall, so it's entirely free. You can just go and watch it. The link to my Patreon is in the description below. So first thing I'm going to do is take the RAM chip and the two logic chips off this board. The resistors and capacitors I can replace easily from stock, but we're going to reuse the big chips at least. Right, I've put Kapton tape around the area to protect it, and obviously I've taken the Agnus chip out, so I don't know how easy this is going to be. Let's just give it a try, and I'll put some flux on it. Right, here we go. Job done. So now let's take a look inside the package. So this is a PCBWay Shared Project. You can buy it yourself directly from the PCBWay website. All you need to do is select it, add it to your cart, select the number that you want and the color that you want. I chose purple, and then off you go. Now this is a 4-layer PCB, so it does cost a bit more than the cheap special offer $5 boards. Let's open it up and see what we've got. I've got it in purple. At the time of ordering, purple was on special offer. So that may still be the case, or it may not. Your mileage may vary. So these are the boards. I just got 5. When you're dealing with 4-layer boards, then you don't get the extra discount for 10. So 10 is going to be more expensive than 5. But just bear that in mind. This is the board. So we've got this way up. That's where the pin header goes. That's where the Agnus goes. So the instructions are on the GitHub, which you can get to linked from the project page on PCBWay. I'm just going to clean the board off. The sprayer's not spraying too well. Do the other side. All the surface mount components are on the underside. So we start with the 3 chips that we took off the other board, the donor board. So U4 is not particularly well marked. Pin 1, you can look at the GitHub for that, and you can see the photograph of it installed, and pin 1 is this one here. What I'm going to do is use some solder paste and heat that, melt that into the board. This stuff has been out of the fridge for a few hours, so it should be up to temperature. Smelt 2 lines of paste along there, and then we get the IC AHCT158. Now you'll see that there is a bar along one end. That is going to be where pin 1 is, and we can just drop that in position. Now this is a relatively low melting point solder. I have the hot air set to 220. Okay, yep, that's done. Then we'll do the same for U3. And the same procedure. Good, that's done. And now finally the big one. So double check this end is pin 1, there's the dot there. I'm going to turn this around just to make it easier for me to place. This will take a little bit longer because it's got more to warm through. Okay, there are a couple of solder bridges on that, so I'll go over it with the soldering iron, and that should sort those out. And then it's just going to be a matter of doing the passives. I'm going to hand solder the passives because they are fairly straightforward. We don't put C2 on. That is only for if the Agnus is labelled VBB and our Agnus is not labelled VBB. So we'll start with the resistor, 150 ohms. That is here. I say this every single time. If you know a decent way of getting this stuff out, I'm going to poke it through. That's it. That actually worked. It's not necessarily a viable way long term. Okay. Right. Let's turn it round. So. Little drop of flux. Little drop of solder. Slide the resistor on, turn it around, there we go. C7, while we're here, is 22 picofarads, which is this. So exactly the same procedure. Okay, so these are 100 nanofarads, and we want 1, 2, 3, 4, 5. And 5. Good, I'll clean those up with some IPA and then we can get on to the next bit. Now we can put the pin headers in. So I've pre-cut them to length. These are turn pin headers. They go in this side here, facing up. So these are 10 pin and these are 11 pin. Now the 11 pin go on the outside, like that. What I'm going to do is put a second board underneath, and that is going to allow the pin headers to go all the way through. So that's an outside one. Like that. The inside ones are offset, so they go around like that, and then these go on the outside like that. Now what I'm going to do is get another board and stick it over the top, and basically this is going to make sure that everything is in straight before we solder it. Okay, it took a bit of finagling. There we go, that's our pins sandwiched, so should pretty much guarantee that they're going to be straight. And now we can solder them. So the final thing to do is put the socket on the top and the pin header for A20. We've got pin headers 90 degrees, we've got our PLCC, and I've got some blue snot just to hold the pin header in place. That's going to go in there, and that's going to hold it in the right position so that we can solder it like that. Now it's important to get this the right way round. There's an arrow there for pin 1, because otherwise it is completely symmetric. That goes in there like that. We'll just use some tape to hold it down. Which will allow us to turn it over, and of course we'll just solder one pin to start with, and then we can make sure it's pressed into place. So we'll do a corner and an opposite corner. Okay, that looks to be in, so we can solder those in, and then I think it should be done. There we go. So now we can put the 2 meg Agnus into the socket, and we should be ready to try it. Here's the 2 meg socket, 2 meg Agnus, pin 1. There is a notch, there is pin 1. Ready to go. We're back at the CDTV now, so let us replace the lash up temporary Agnus with the 2 meg one. Right, so let's take that out. Don't need that anymore, and we should be able to just plug this in. Now, unfortunately, the cover came off that, so we're just down to bare metal, but we should be able to just plug that on there like that. Okay, so the moment of truth, is this going to make any difference? I'm going to get my Mac set up and make sure that the monitor is running. This is either going to work, going to be exactly the same, or it's going to be a complete disaster. Take your bets, please. Right, basic power on is fine. Here we go. We are diagram. And we're getting a memory failed. But it is kind of booting and talking. Okay, we seem to have 2 bits that are wrong according to the output on the display. So we've got, I don't know which way around they are. It may well be just that the memory chip is bad, or maybe there's a bad connection, but it does look like it's not quite the same. It's not quite just 2 bits. It looks like a pair of bits. A pair of bits that when you write 0 is fine, but when you write 1 it comes back with a 0. So I'm going to guess 4 bits are stuck at 0. So looking at the monitor output, the 2 bits that seem to be stuck, and we're looking at 32-bit words here, so basically it's split into 2 16-bit words and read I guess consecutively using the RAS and CAS signals. So we've got a 16-bit data bus on the Agnus, and those 2 bits correspond to data lines 12 and 13, which is pins 1 and 2 on the Agnus. And we can see, because we can see that happening twice, we know that it's both pins 1 and 2 on the low word and on the high word. So that tells us really that it's those 2 pins on the DRAM that are giving us the problem. So we can have a look at those 2 pins. This is the nice thing about this particular board, because it makes it so much more easy to debug it and put a probe on there. So let's just stick our scope on and power it up and have a look at those 2 pins, pin 1 and pin 2, which is DRD12 and DRD13. So we've got red and green flashing, and this is pin 2. We've got the pin 1 label there, so that makes it really easy. So this is pin 2, which is DRD12. And yeah, that seems to be, oh, there is a bit of activity there, but it seems to be generally 0. And this is DRD13. It's the same, it's mostly 0. We've got a bit of activity. Let's have a look at some of the other pins just for comparison. I have checked that they're not actually shorted out to anything. So that's DRD14. It looks more or less the same. DRD15. And they're definitely not shorted together. And this is H-Sync. Yeah, that's good. That's going to be ground, and it is. This is going to be C-Sync. And down here we've got DRD2. That's quite active. DRD1 is quite active. 4, I think that is. 6. 8, and we can see it getting slower apart because I guess it's counting through. 12, sorry, 10, and that's 12. So it looks like in general the data bus is behaving itself okay, but we're not seeing good values from that memory. So maybe we have a bad connection on the RAM and we can't check that because it's on the back of the board, or maybe that RAM chip is duff. But let's power it down and just have a look and see if we can figure out which pins DRD12 and DRD13 are connected to, and then we can see if there's a good connection there. Now I've taken this out and I've checked on a blank one exactly which pins should be connected to our 2 points, and they are these 2 pins here, right by the C3 designator. So I think you can see if we zoom in. If I turn that slightly that way, we might be able to see. I have to push it back a bit. Might be able to see it does look like they are possibly shorted. And if we beep it, that one and that one, yep, they are definitely shorted. That, I think, is going to be our problem. So I'm going to fire up the soldering iron and we're going to see if we can clear that short. So these are not actually D12 and D13 on the chip, they're actually D4 and D5, but there's no reason that the designations on the chip itself have to correspond with the designations on the address bus or the data bus. As long as they are consistent, I'm going to put some flux on here. That's just going to help us to melt the solder, and we're going to have a little bit of solder wick just to soak it up. I think the problem is that there's solder on the pins. So that's definitely got some solder off. Let's just beep them out again. Yep, they are no longer shorted. Right, let's give this another go. Okay, 2 Meg Agnus take 2. Power to the machine. Oh, that looks a lot better. But we've still got the address error. So I think that tells us that the 2 Meg Agnus itself is fine, probably. The chip RAM is fine, probably. Leastways there are no obvious bit errors. But there's still something wrong on the main board. So what is it? We've changed the buffers, we've changed those buffers. We haven't changed these buffers or these static RAMs, but I'm not sure that they are the problem. I mean, maybe they are. And we've got a couple more 244s there we could change. I'm kind of poking around in the dark here, so yeah. Now I just pulled the new adapter and reseated it, and now we get this. And yes, we're actually getting stuff on the screen. So we can actually take the remote control and we can press the A and B buttons, and that is going to give us the system info. There we go, if I do it in front of it. And that tells us we're on a 68,000, we've got 2 megabytes of chip and the base address and so on. It doesn't allow me to use the other keys. I can just go back to the main menu. I don't know if it's a problem with the remote control or whether it just doesn't accept input from the controller, but it does accept the A and B key. Doesn't seem to do anything else though. So we can see custom chip registers, all that stuff. I don't know if it's okay. It comes out as green at least. I've got a thought. Let's restart it and see. So I'm going to get it to the point where it's sitting there waiting for a key input. So all this has failed before and it's thrown loads and loads and loads of errors, but it's now just going straight through. Ah, there we go. So let us try 2. Aha, now it's working. Right. So this is exciting. It's not got this far before. Oh. Well, that's not so good. Okay, let's reset it and start again. I don't have the speakers plugged in. I should do that, then we can do some audio tests. Oh, no. Right, fresh batteries. I have plugged the audio in, so maybe we'll be able to do some audio tests. Let's power it up. Okay. Right, that's a bit better. Okay, this is the chip mem test. Okay, that's failed again. I wonder if that indicates an actual RAM problem or whether that is something on the main board. Let's restart it and go back to the main menu and do some other tests. Okay, memory test. Sorry, audio test. I don't know if it's the remote control, but we don't seem to have very much keyboard input. But we did get sound out, so that's a good thing. Now I've got the Kickstart ROM in, so we're going to see whether it actually does something, if it's going to boot or not. I have no idea at this point. Your guess is as good as mine. Right, on the power, fire it up. Flickering. Obviously we don't get any serial port output in this mode. Ah, we've got a yellow screen. Eventually. Flickering. No, seems to be nothing. So we seem to be black screened, which is positive in the sense that we know we're actually getting a video signal, but we don't seem to be starting, or at least we don't seem to be getting very far. Okay, I've got the sound playing. And it's glitched again, and what you can see on here is a random pattern on the screen, and it's flashing very occasionally to one of the graphic images that is part of the ROM. So I'm wondering if there's a ROM error or an addressing error in the ROM. I'm going to try. Okay, so a development. The situation that we have with this is that we can run diagram and get to the main menu, and we can start running any of the tests, and after a short period the screen display goes to garbage, and that's repeatable. So I asked around on the interwebs, and what has come up is that it is most likely to be the Agnus. So I took the Agnus out, and here it is, and put that into my Denise, and I got exactly the same result. So it started up and very quickly it went to screen garbage. So I've taken the Agnus out of my Denise, this is my Agnus, my 2 meg Agnus, and put it into here, and we are about to try it and see what happens. I've not done this before, so you're seeing this the same time that I'm seeing this. Okay, we're still running diagram 1.3. I don't know if the remote is going to work. Sometimes it does, sometimes it doesn't. We shall see. It does help if I turn the screen on. Right, okay, so we're starting up. I don't have the monitor plugged in. The monitor on the serial bus always went through to completion every single time. So, okay. Right, memory tests. Detect chip RAM, let's see if it goes all the way through. In previous tests it's got to about 260 in the checked memory section before it craps out. That is looking very positive. Okay, that's going round again. So I will do a long-term memory test at some point. Okay, I'm going to go and change the diagram and put Kickstart in, and let's see if we can boot the machine as a CDTV. I'm going to... Okay, the regular Kickstart is in. Let's see if it will boot to the main CD-ROM. Nope. We're still getting the yellow screen. Okay, well, back to the drawing board on that. But we have built the new Agnus daughter board, 2 megabytes, and it does work. We have seen it going in diagram. As far as the CDTV is concerned, I don't know at this point if If I take JP15 off, that's this jumper here, and this is now in the off position, that is going to boot the machine into A500 mode, which means it will come up with an insert workbench disk screen, just as if it was an Amiga 500. And I've had to take the Hyperion ROM out because that appears to not work, and replace it with basically my own burning of that Hyperion ROM. And this is what happens with Kickstart in here and JP15 turned off. And here we go. Yay, it's success. So the red workbench screen, I believe, is because there are no actual physical drives attached to the machine. So if we plugged an actual floppy drive into here, then it would find something to boot from, I believe. But yes, that is working. With this JP15 set, then it doesn't boot, it just comes up with a yellow screen and it says, yeah, we don't want to know. So that to me suggests that something that is CD specific, so one of the CDTV specific chips, is possibly causing the problem. But I don't know, that is purely a guess at this stage. So it could be that, or even these ROMs. I can put the original versions of these ROMs in and see if that makes a difference. So I've gone back to the original Kickstart 1.3 and the original extended ROMs. So everything is basically factory default there. And this is what we get. JP15 is attached. Here we go. Yay! We have success. Now any other combination, the where did I put them? These extended ROMs or this workbench or combinations of those two, and it doesn't work. But put the original Kickstart in and the original extended ROMs in and we get a booting CDTV. So yay! If you've got this far, thank you for watching. Please like and subscribe and do all the things that YouTube loves you to do. Hit the boost button if you're on a mobile phone, device, tablet, etc. thing. And I'll see you next time. See you next time. Bye.